problem set 87 today. More on systems of equations. So, we're going to start with, and I hope you're all taking notes because I'm going to have you do this whole problem yourself. You thought it was my job to teach. It is, but you can do the work too. So, they are upgrading your plugging into gross systems of equations problem. So, now you're going to see something that looks like this. So instead of this equaling a number, they're equaling each other. They give you RE equals 200, RW equals 250, and TE plus TW equals 9. And you're meant to find TE and TW. So you've basically already done these. So I want you to give it a shot, and then I will review. You viewed once, and I will review your answers with you. Go ahead.
Wait, how do you do that one again?
Start plugging things in and go from there.
I forgot how to do the...
You know how to plug in a number.
No, not the RE and RW, but the
I know.
T.
Keep going. Just start the problem. It will illuminate your eyes.
It will not do the illuminating. Tell me what. I forgot.
Well, do the first step.
I know.
Don't just sit there stunned like, I don't know how to do anything. Write something. Do the parts that you do know how to do. If you've convinced yourself you know how to do nothing, then you've convinced yourself of a lie. The worst person to lie to you is yourself. Did you plug in? Cool. How do you solve systems of equations? We know 3 ways to do it. So substitution, elimination, and graphing. Everyone doesn't like graphing. So choose substitution or elimination and solve. Substitution or elimination. Come on, bud. You got this. You start writing.
T equals CW in both sides.
That's how you gotta do it.
Well, that's not how to do it.
Substitution or elimination. That's how you do it. I'll try something. Try something.
I don't know what.
No, trying nothing is not working. So, try it. Maybe.
I mean, do that, but it worked.
Okay, try something. No.
Pastor tomorrow, is that,
That's in my class. My numbers.
okay, so it's lesson like 38 to 40,
40. Maybe it's like a 40.
oh, okay.
Right?
Because we're on lesson 47 now.
Yeah. So it's like that's 40. Huh, I should have done 44, but I didn't. That's good. All right, first step, everybody, plug in. What? Which number? What's the first number you plug in? RE is not a number. 200. 200 is a number. 200 goes in there. We don't know TE. That equals, what do we plug in next? 250. TW. Okay, the other equation is TE plus TW equals 9. Can you solve that? Sure. Use substitution or elimination. Me drawing this little curly thing next to it should do nothing for you. In fact, I'm going to stop drawing it forever. You now know, don't get that. No, get that. Use substitution or elimination. What would make sense?
Eliminate the
Substitution. Why? Because these are on opposite sides of the equal sign. I don't want to deal with that. So I'm going to solve for TE. Equals 9 minus TW. and plug it in. 200, 9 minus TW equals 250 TW. Can I solve this?
Yeah.
Sure, you have one equation in one variable. 200 times 9 is, everybody, come on. 1800 minus what? 200 TW equals 250 TW. Final step, AJ?
Divide, or wait, no. Yeah, divide.
Add, subtract, multiply, or divide.
Subtract.
So if I subtract, I'm going to get double negative, so I must
So you add.
add.
200
The opposite of subtraction is addition. Okay, what's the answer? Evan. Go ahead, you did it on your own. You've got the answer.
18, oh, the answer, 0.25.
What?
I disagree. So you have 450 here, you have 1800 there. 1800 divided by 450 is? Go ahead, quickly. You're on the hook.
Swiftly, Evan, swiftly.
What do you got?
5.
Close. It's 4.
What?
Then, once we've done that, we plug back in. This is 9 minus 4, which is 5. That's it. Question.
So in the top part of the equation, can you make, I guess, can you basically flip t plus tw equals 9? So can you make that into, I guess, 9 minus tw?
That's what we did right here.
I know, but, never mind.
Do it earlier. Yeah, that's fine. Sierra?
You can do that.
How did you rearrange it? Because I got 5 for TE and 4 for TW instead of.
That is what I got as well.
Oh.
Yep, TE is 5 and TW is 4.
Oh.
That's perfect. Okay, so that is that. Now, we are moving on to the second part of our lesson. Okay? Remember that sitting up straight in your chair will help you be attentive and ready. Reclining in your chair will make you go to sleep. Sir, your cap is on. Thank you. Welcome. I know many of us try and hide amongst our hoods, but it is time to be present. All right, the next thing is we are going to test for functions. What does it mean to test for functions? They are going to provide you with graphs and ask you if it's a function or not. What is our requirement to be a function? You guys remember? Check back in your notes. I have one person who took notes. Look back. Look back in your notes. What's required to be a function? We covered this in... Wait, hold on. Raise your hand. Everyone's got 2. You only have to use 1. Problem set 84. Cool. Raise your hand then. Okay, I have 2 people who looked back in their notes. Problem set 84. What's required to be a function? I wrote it. I was like, hey, know this. Okay, I got half of the class. What is required? Go get a drink. Obviously, you're not willing to allow the other students to wait, so I'll send you out while they're processing, and then you can come back. Goodbye. All right? All right, more than half of the class. We're almost there. Check your notes. Problem set 84. All right, almost there. The answer is Ocampo?
No solution is inconsistent.
That's not it. Sorry. Kara?
One output.
Every input
Oh, has an option.
has one and only one output. And then remember, we talked about domain and range. If you don't have it written down or easy to find, perhaps writing it down in this lesson would be useful for you. We talked about domain goes with which letter? X or Y?
X,
Domain is X, range is,
Y,
And so the domain are the numbers going into our function. So instead of input, I'm going to erase this and put x. Every x has one y. And so today I am introducing to you the vertical line test. So if you have a function graphed, then you can find out if it's a function or not by using a vertical line. And if the vertical line touches your graph more than once, it is not a function. Why? Because for this x, it crosses more than once. In fact, how many times does it cross? 1, 2, 3, 4. Does that x value have 1 y? No, it has 4. Therefore, it is not a function. So, as you put your vertical line across your function, you can do this on your paper as it's written down. You go across. If it touches more than once on any vertical line, then it is not a function. Let's look at example B. This one is a function. Why? Because I can take a vertical line and go across my function, and it will only ever touch once. Okay? Just one time. Now, if it only ever touches once, that means that every x has only one y, or every input has only one output. And therefore, this is a function by our definition. Example A, not a function. Okay? A good way to figure that out is, does it double back on itself? Like, does it go back, or does it always go forward? Is a good way to keep track of that. Let's look at this one. Example C. Function or not a function? Hold it. Think about it in your head. Give it a moment. Is example C a function or not a function? Okay, thumbs up if it is, thumbs down if it's not. All right, I have sideways thumbs. That was not one of the answers. All right, I have 2 thumbs ups. I have 4 thumbs downs. The thumbs downs have it. Why? If I put a vertical line anywhere on this, I will see that it touches twice. Therefore, it is not a function. Okay? All right, that's your lesson. You may begin your homework again.